Let's do this example in page 4 of our slides. We are given two vectors u and v. The vector u has coordinate 0, 0, 1 in R3 and v has coordinate 0, 2, 2. If we are asked to find u dot v, the easiest way now to solve the problem is to use the component form of the dot product. ui multiplied by vi and sum for the three coordinates. And now simply we'll have 0 multiplied by 0 plus 0 multiplied by 2 plus 1 multiplied by 2, and the answer is 2. We can come to several conclusions. The first conclusion is that the dot product is a positive number, and therefore the theta must be an acute angle. Right, we'll now redo the problem of u dot v using the other formula. The other formula is the definition of u dot v. We want to convince ourselves that both formulas will work. So let us begin. Let us find norm of u. Norm of u is simply the length of u, and it is the length of, or we can use the Pythagoras theorem, which is simply the square root of the component square, and the length of u is 1. What about the length of v? It is 0 square plus 2 square plus 2 square, and we get the answer 8. And lastly, we need cosine theta. Theta, as we remember, is the angle between u and v. In the figure, theta is shown to be 45 degrees, and if we plug in 45 degrees as theta, we convert it into radian and we find cosine theta, then we can use the equation, and the answer using this equation over here will be the same, equals to 2. Now maybe we'll address the last question. How can we find theta equals to 45 degrees? Well, in this R3 examples, it's actually relatively easy. U is a vector, and we can draw it in the R3 form that points to only to the z direction. So if we have x direction, y direction, and z direction here, it is the vector that has 0 components on the x-axis, 0 components on the y-axis, and it has unit length at the z-axis. What about vector v? V has the component 0 on the x-axis, 2 on the y-axis, and 2 on the z-axis. What we can then infer is that the x-axis does not play any part in drawing u and v, and we can just simply focus on u and v on the yz plane. If we ignore the first part, then what we can see is that u is a component along z, and v is a component that is 45 degrees between z and y, and hence it is now obvious to us where the theta came from, the 45 degrees value. Actually, the typical way to solve the problem is to do this. U dot v equals to norm of u, norm of v cosine theta. And because we are interested in cos theta now, we will reduce the equation to u dot v divided by norm of u, norm of v. And because we can use the component form of u dot v very quickly, we can calculate it in, and we can also find the norm of u and norm of v quickly. We can also do it this way, leaving with us the value of cosine theta in this form. And then simply theta will be equals to cosine inverse this value, and it should be 45 degrees in radian.